As today's class took a lot longer than I thought it would to get through the material I wanted to cover today, I thought I would go ahead and send this slideshow home to families so that all students could finish it at home. So what I'll do is I'll go through quickly the first few slides, or the slides we did in class, and then talk about that which we didn't do in class. So first we started off with a quick concept quiz. This was a quiz on constant proportionality as well as writing an equation. Just asking the children as they came in, only to discover that only about 3 or 4 of them actually watched the quick 12-minute video I sent home last Thursday explaining constant proportionality and how to write it, as it was obvious through the mid-module assessment that many were still confused. So I have sent that home again, and hopefully you will please have your child watch that, and you as well. Okay. So lesson 18, computing actual lengths from a scale drawing. We did this first activity there with called basketball at recess. The whole idea was to actually use this scale drawing that a student had put together for a half-court basketball court, and he was proposing putting it on his school grounds. He had a certain size lot or a certain size spot, 25 feet by 75 feet, in which he could put it. Gave them the scale. As you can see right here, the scale, 1 inch equals 15 feet. And what we talked about here is we talked about the difference between a few things, and I'll get into that more, but the two things were scale factor and scale ratio. Now those two are indeed related, but different in one critical way, and we'll see that as we go along. So as you see, for this given scale here, we took this 1 inch equals 15 feet and also used 180 inches for that 15 feet in order to create a scale factor. This was our scale factor we used when we found these lengths and widths. And we did this in class, so I'm not going to go over it. The children have notes in their binders already. So let's see, we'll move on here. And then we asked some questions, where have you seen the term scale before? And they gave me a few places, and then we just went ahead and passed out some topographical maps, and we located the scale on those. And we asked this question: is the relationship between the map measurement and the actual measurement, does that represent a ratio? And the answer was yes, it does. If 1 centimeter on a map represents 20 meters in the real world, the ratio is 1 to 20. This is called the scale, or sometimes the scale ratio, and we see that a lot on the maps that we use every day, road maps, etc. So, and this is the scale ratio, which is again different than the scale factor idea that I had mentioned before. So let's go ahead, go next. And then ask the question, is this scale or scale ratio the same as scale factor we have been talking about? And the answer was indeed no, it is not the exact same. The scale factor is always expressed as a relationship between distances measured in the same units. And this idea of same units was what I was trying to get across, because the reason why this was important, therefore, was that the scale factor needs to use the same units in its calculation as it seeks to compare the magnitude or actual percent difference between the size of a scaled image and its counterpart. Okay, so whether an actual image or object was a further reduction or an enlargement of the scaled image. So, for example, when we had this first one here, first one that we did there, right here with the basketball court, we can see if we have this scale factor, we know the scale factor is going to tell us that this actual actual basketball court is going to be 180 times bigger Okay, and as we can see, it is, by this we can see that it is 180 times bigger than the scale drawing. Let's go back to, hold on here, get back there. Okay, and we looked at this this example here, this scale, and this is the actual scale that we saw, a very similar scale on the topographical map that we were working with, actually the exact same scale, and we talked about this example scale. So this right down here, this 1 inch equals 24,000 inches. That is the scale factor. Okay, but we also talked about the reasonableness of using such a number. We had a road that I had them measure with the ruler, and it was 1 inch, and that inch would have translated into, of course, 24,000 inches. But we talked about how practical that was to say, oh, it's 24,000 inches down the road. Not very practical. So we talked about what would be a better thing to use, and we talked about that scale ratio. So that scale ratio is a little bit clearer. Now we have 1 inch equals 200 feet, or 2,000 feet, and we could see that right here when we measured this section right here, and it was 1 inch, and 1 inch equals 2,000 feet. So this would be a bit more practical if you're going to try to determine how far two locations are apart. But this scale factor, of course, is used to represent how much bigger this the real Knights Ferry. We were looking at Knights Ferry topographical map. The real length of the Knights Ferry Bridge, for example. Not in inches, but rather in feet. Okay, so question: do we always need to use a scale factor in order to find actual measurements from a scale drawing, or could we just use the given scale ratio? And that again goes back to to this question: which one's better to use? I mean, do you have to use the scale factor? And the answer, of course, is no. No, we can use either. Depending on the situation, one may be more practical and require less steps than the other. And very often with scale factor, you need to convert first, as was the case in the basketball court problem. You needed to convert, and actually the problem coming up has that same aspect. And here it was this one. This is the last thing we did before they left. The diagram shown represents a garden. The scale is 1 centimeter for every 20 meters of actual length. Find the actual length and width of the garden based upon the given drawing. Each square in the drawing measures 1 centimeter by 1 centimeter. Now, before I move on to the next slide, which has the beginnings of a table, which I'm trying to promote that they use, the one confusion that did come up was that they were confused in the size of the garden, because here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And some were actually assuming that they were talking about a garden that was 12, or a scale drawing that was 12 centimeters in length, whereas they were just concerned with, of course, these 8 centimeters right here, okay, because that's the size of the garden. The rest is just something that's used to actually guide their measurement. Anyway, just be able to look at diagrams and really understand what they're actually showing us. Okay, so here again, I'm trying to promote that they use tables as much as they can, and right here we just plugged in the information we had already, which was the 1 centimeter in actual 1 centimeter on the scale. Actually represents 20 meters in the actual. Okay, and then we could actually use that scale factor, and remember we're talking about the scale factor as being very much like the constant of proportionality, which is y over x, or y as a function of x. So that would be 1 over 20 or 1 to 20. And then using those, we could then apply that scale factor to find out that something that's 8 centimeters in length on the drawing would then be 160 meters, because it is also, if this, 1 centimeter to get to 8 centimeters is times 8, you would do the same here. Now, if we were going to actually use a scale factor, we would want to put 16,000 centimeters, okay, because there are 100 centimeters in a meter, okay. And we did the same over here, and again, the kids should have these answers. This was 80 meters, okay, and this was 8,000 centimeters. So the next problem we didn't get to at all. This was example 3, and the problem goes: a graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 25 hundredths of an inch, 0.25 inches on the scale picture, will correspond to 1 inch on the actual advertisement. What will the length and width of the tablet on the advertisement be? So excuse me here, but I'm not exactly sure where I was. I I left school, running out of battery, had to go pick up my daughter, and now I'm back. But I'm going to go ahead and read example 3. I think I read it already, but I'm going to read it again anyway. So this is example 3. This is the problem we would have been doing in class had we would have been doing next in class if we had time. Okay, so example 3. A graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 25 hundredths inches on the scale picture will correspond to 1 inch on the actual advertisement. Okay, and of course 25 hundredths, that 25 hundredths there, let me just mark it right here. Okay, we know, and hopefully you know, that's the same as 1/4. Okay, up to you to choose what type of fraction you like to work with. Do you like decimal fractions? Do you like regular fractions? Okay, but anyway, the main point here is that so every 1/4 inch on the scale picture will correspond to 1 inch on the actual advertisement. What will be the length and width of the tablet on the advertisement? Okay. Now, like we found out in class today, and like I've been telling you over and over again, don't rely on these packets to have reliable sizes, okay, these images. So I'm going to go ahead and just give you these the sizes that they indeed are. Okay, so this this little tablet here, or this image of the tablet, is okay. I have it right there. Well, let me see. I had a next image here. Maybe that's why. Okay. Alrighty. So hold on 1 second. I'm going to pause and figure out what's going on. Well, I'm not exactly sure what was going on there, but anyway, here are the dimensions that I want you to use. Okay, 1 inch width, 1.5 inch or 1.25 inch length. Okay, or height. All right. So now, prior to this, we had talked about using the. Let me go back to what we had done prior. Still can't get there. Okay, there we go. All right. So we had talked about using. First, when we talked about this the garden. We had talked about using scale ratio. Then we had talked about using scale factor. Okay, and in scale factor, you need to convert first. And now we are talking about using an equation. Okay, so using an equation to actually solve this problem. Okay. All right. So if we do know that we have each 1/4 of an inch will correspond to 1 inch on the actual advertisement, we can go ahead and figure out our scale here. Okay, the picture. Okay, which is what we see in front of us again. Okay, I got to find those dimensions again. There they are. Okay, 1 1/4 inches in length, 1 inch in width. Okay, so we can go ahead and then put those right here. We have length 1 1/4 inches. Okay, and we have width of 1 point. Sorry, width is 1 inch. Okay. All right, so we have 1 1/4 inch length, 1 inch width. Right. Okay, that's what we have. So now she needs to enlarge it. So the picture given here, so that 1/4 of an inch on the scale picture will correspond to 1 inch on the actual advertisement. We will know that our scale, therefore, is 1/4 over 1, because we're taking this. So for each quarter, I'm choosing to use fractions. I mean, yeah, and you can use decimals if you'd like, but so every 1/4 of an inch on this picture, okay, or this, the scale drawing, will actually equal 1 inch on the ad that they're trying to create. Okay, so if we go ahead and then figure what our scale will be, okay, and you remember our scale, and our scale factor is going to be, remember k, just using that constant of proportionality, k equals y over x. And then if we go ahead and punch those numbers in, that would be 1/4 over 1. Okay, and then remember, when we're dividing this complex fraction, we're going to take the 1/4 and then we're going to multiply by the reciprocal of 1 over 1, which happens to be 1 over 1. Okay, because the truth is here, you are just dividing 1/4 by 1. And you know, anything divided by 1 is that thing itself. Okay? So we actually have our constant of proportionality, or our scale factor right here, is 1/4. Okay? So k equals 1/4. And let's remember that, because we're going to need this when we plug it into an equation. Okay, so we're back. I've now turned to, or switched to the next slide. And again, the third method we're using right now is this using an equation. Okay, and with this equation, we're going to need k. Okay, and we have k as being 1/4. Okay, and that's our constant of proportionality. I'm going to go back to that. I don't know how I did this, but here it is right here. Remember, we went ahead and found our scale factor right here by using these numbers, which came from here. Okay. All right. So we got that. So we got our k, which is our constant. All right. Now we're going to just use it over here. So we have k equals 1/4. Now, the first equation we can use is this one here, which says y equals k times x. And I think a lot of you will be familiar with that one. Okay, y equals k times x. All right, so we are trying now to, because we have y, we have k, we're just trying to find out x. Okay, so let's plug in some numbers. So if I'm going to do that, if I have I'm going to use this equation, I'm going to plug it into this right here. If I have a y, okay, and my y is a scale picture on the tablet, so let's work with the 1 inch first. It's an easy one, right? So 1 equals 1/4 x, okay? Because I have my k, here's my k. All right, my k is 1/4, so I plug that in for the k right here. And just see there's the k right there, okay? So that k is right here, okay? And then choose a new color. Why can't I choose a new color? Why do we do this? Whee, there we go. I don't know if you can see that, but that's pretty cool. Okay, now another color. So, and here is our y, okay, and our y is right there, and that y comes from right here, okay. And now our x is this is our unknown, okay. That's our unknown, okay. And that x, of course, is known as a variable, just as y is a variable. In this case, our y we've plugged in there, okay. So you can look at this right now, and you could say to yourself, you could ask yourself, what number, right here, what number times 1/4 equals 1? And I think many of you know that. But let's go ahead and do this how we would do it algebraically. Okay, so let me go ahead and just give us a little room here. I'm just going to bring all of this out here. So a little step by step. Right now we're at this point. We have 1 equals 1/4 x. Okay. Now, if we're solving for x, it's always handy, and it's a good habit to get into, is bring the x portion over to the left. Okay, so 1/4 x equals 1. Okay, because it's always nice at the end we have x equals something, or if we're solving for y, y equals something. Okay, but it doesn't really matter, but it's just handier and a good habit to get into. So 1/4 x. So we're trying to, and again, this is easy, and I mean, it's easy to do without going through all of these motions. I do understand. But when these problems, these solutions get more complicated and they have multiple variables, okay, really, really very important that you know how to follow it and you do it step by step. So now we have 1/4 x equals 1. So what we want to do is we want to isolate this x. We want this to get to be just 1x. And if you remember, what we do is we are going to then divide by the 1/4. Okay, divide by 1/4, because we divide 1/4 by 1/4, it's going to equal 1, and that's going to leave us with x. Okay, but of course we know, and we've learned, when you divide by 1/4 or whatever, you're going to divide by the reciprocal. Okay, so you multiply by the reciprocal, so you're actually multiplying 4/1 times 1/4, which equals 1x. And 1x is the same as just plain old x. Okay, so just x. So x equals, now whatever we do to this side, we need to do to this side as well. So then I'll take 1 and I'll multiply that by 4/1, because that's the reciprocal of 1/4. Okay, and of course 1 times 4/1 is the same as 1 times 4, which equals 4. Okay, so x equals 4. So if we went back to here, we would know that the width, when the width is 1 inch on this picture, is going to be 4 inches on the actual advertisement. Okay, all right, because, and you can see it, the scale factor, right? The picture, the scale drawing, is going to be 1/4 the size. See that right here? 1/4 the size of the actual ad. Okay, and that makes sense because 1 is 1/4 of 4. Okay. So then if we go ahead and let's solve for the other one. Let's solve for the, let's erase all this. We've solved for the width. Let's go ahead and solve for the length. Okay. And again, do this step by step. Hopefully if you want to pause right now, you could pause and try it yourself, or you could just follow along with me. Okay. So let's go ahead and we'll choose a choose a new color for. Okay. For this, so we're going to actually do that now. Here we have our y. Okay, so our y now is 1 1/4. Okay, so let's go ahead and put that. So y 1 1/4. But I remember now someone in class, I forgot who it was. I think it was Jacob. He preferred, and I am very happy that he said that, but he preferred to turn that 1 1/4 into actually an improper fraction. They work much better, and you're going to see that as you get into higher algebra. Okay, so here we go. We have our y. Our y is represented as 5/4, or 1 1/4 over here. Okay, that's our y. So y equals k, and we know our k. Our k is still 1/4. Excuse me. Again, my color again for a new color. Okay. I get some weird colors here, but anyway. Here is our k. Okay. Because I'm just trying to show you how this equation over here, how this equation relates to what we're building over here. Okay. So right now we have 5/4 equals 1/4 x, and again that x is our unknown. This is what we are solving for. Okay, we're solving for that x. We're trying to find out how big the actual advertisement will be by applying our scale factor and what we know about our picture already, our little scale drawing. Okay, so here we go. Let's go ahead and excuse me, make some more room. Okay, so now we have 5/4 equals 1/4 x. Okay, do put the x on the left side because it's so much handier. Again, it doesn't make it wrong if you do it the other way, but like I said, I think it's a good habit. And again, we're going to multiply. We're going to divide that 1/4 x by 1/4 just to make it x. But of course, we know that to divide a fraction, divide fractions, you multiply by the reciprocal. And here we go again. We did that. So we're left with x only because 4/1 times 1/4 equals 4/4, which equals 1. And then we're going to do the same thing to this side. So we're going to multiply 5/4 times 4/1, okay, which equals 20 over, oh, actually, no, hey, let's do our canceling. Cancel that, that's 1 and 1. And then we get 5/1, which equals 5. Okay? And we go back to our thing. And now we would have 5 as the length of the actual advertisement. And it's pretty easy. You can see that. You can see 1 1/4. If you took 1 1/4 and took it 4 times, it would equal 5. Okay? And 1 1/4 is actually 1/4 of 5. Maybe not as clear to you, but yeah, I mean, hopefully it will be. Okay, so there we go. We've used an equation. All right, and I would love for you guys to use equations more and more. I know somebody, I think it was Lila, wanted to use an equation today in class, and I think that's wonderful. Okay, as long as we know what we're doing and why we're doing it. All right. Okay, so now we have a question. We asked a couple of questions in class today. Here's our question right here. Is it always necessary to write and solve an equation y equals k times x to find actual measurements? So my question is this: is it always necessary to use that equation in particular? Okay, and of course, to use that equation, we would need to know y, we would need to know k, okay, and we usually have. So, well, the answer is actually actual measurements can be found by applying any of 3 relationships depending on which information with which, depending on, blah, should be depending on the information with which you are working, okay? And those different equations could be y equals k times x, which is what we were just working with. Okay, I can't actually keep that correct. So I'm going to go ahead again. X equals y divided by k, and k equals y divided by x. Okay, those are all you could use any and all of those to solve problems. Okay, so let's go ahead and look at that with what we had. So we had k equals 1/4 for this problem. Okay, and then we knew that in one case y equaled 1 inch. So let's plug these in, and let's go ahead and use, we've used this already, so let's not use that now. Let's use this one, x equals y divided by k, this one right here. So now we would go x equals, we have y, okay, which is 1, and then we have k, which is 1/4. So 1 divided by 1/4. So let's go ahead and do that over here. 1, if we looked at 1 over 1. Now if we divide by 1/4, we are multiplying by its reciprocal, right? So that would be times 4 over 1. And of course, 4 over 1 equals 4. And yes, we got the right answer, okay? Because that's the same answer as we got over here. And I'm not getting there. I think I lost that one. Okay, anyway. Yes, so that's it. So that worked with 4. So that worked. Now let's go ahead and try, let's try the k. Oh, we still need those. Okay, let's try this last one. K equals y divided by x. Okay, so now we have k, which we know, we're working with this one here. We're working with this one. Okay, we did that one now. K, we have k, 1/4 equals, we have y. Whatever happened there? Y divided by x. Okay, because y is 1. All right. So 1/4 equals 1 over x, or 1 divided by x. Now, again, let's go ahead and let's just swap places with these here. So it's a 1. Let me make it a little bit smaller so we have some room here. 1 over x equals 1/4. Okay, and again, we're working with this, but I just put it just the opposite way. Now, again, we want to isolate. We want to isolate the x. Okay, we want to go ahead again, and we're going to multiply by the reciprocal. Okay, so we have x over. So then, if we know we have 1 over x equals 1 over 4, then we know to make this true, x would have to equal 4, because 1 over 4 equals 1 over 4. Okay, so if you have something like this, and you can see that it's 1 over x equals 1 over 4, you've pretty much have it done for you, because you have the numerator as 1 in both of those, and all you're doing is trying to make this true. Okay, and if you do make it true, you know that x has to equal 4, because 1/4. So, and again, you did get 4 again, and that worked out. So you could use all of these. There's different levels of difficulty as you use those with certain equations. So with certain numbers and certain values. Okay, so this last problem about this mall entrance, I'm gonna go ahead and read it to you right here, so we can maybe highlight some important information. Students from the high school are going to perform one of the acts from their upcoming musical at the atrium in the mall. The students want to bring some of the set with them so that the audience can get a better feel of the whole production. The backdrop that they want to bring has panels that measure 10 feet by 10 feet. Let me just just stop right there a second. I just want to highlight some things. So this idea, the backdrop. Now, I'm not sure how many of you have been to many plays, but the backdrop is the scenery in the back. So it might be trees painted on, big pieces of plywood. Okay, and those are 10 feet by 10 feet. What might be handy just to get a sense of how big that is maybe measure that out in your house. Get a ruler or a measuring tape or something, and measure out 10 feet by 10 feet on your wall, and just so you get an idea. Be kind of a little bit more real when you actually see it. So okay. So anyway, I'm going to just continue. Now again, the backdrop that they want to bring in. Okay, they want to bring these to the mall so they can actually have their audience get a real feel for it. The students are not sure if they will be able to fit these panels in through the entrance of the mall. Okay, so they're trying to get them through here. Okay, since the panels need to be transported flat. Okay, so panels need to be transported flat. Okay, or horizontal. Okay, and of course we know flat or horizontal is this way. Versus vertical, which is this way. Might be easy to get them through vertically. You pretty much guaranteed to have a 10-foot clearance, this way. But no, they have to be transported this way. Maybe there's some things that can fall off of them. I'm not quite sure why, but I guess it wouldn't be a problem if there wasn't something special like this. So yeah, they need to be transported horizontally, okay, which is real important. And you can see we have a scale drawing of that horizontal mall entrance right here. Okay. All right. So they obtain a copy of the mall floor plan, which is this you're looking at, shown below from the city planning office. So use this diagram to decide if the panels will fit through the entrance. Okay. Oof. Using a ruler as a measure. I wouldn't bother doing that because, again, they give you what you need here, okay? They give you the measurement you need right here, 3/8 of an inch. Okay, and and the scale. So what I want you to do is I want you to complete this, and first of all, let's go to the next page. Okay, so the next page is this. I want you to go ahead, complete this activity, mark it up as much as you need to in your book, okay, in your binder, and then I want you to go ahead and take a photo of it, okay, a snapshot, or scan it, however you've been doing it successfully at Google Classroom, and then go ahead and submit it at Google Classroom. Okay, I'll go ahead and make this an activity. So that is it's in your binder. There's the one page that you'll need to submit it. And in your binder, the page has the two questions A and B on them. So if you go ahead and just do all your work on that page, it is a one big page, pretty much all blank except for the two questions. Do all your work, draw your tables there, and then go ahead and take a photo of that one page. You're not going to be able to. You won't be submitting this, okay? Because that won't be on the page you submit. It'll be the page that has these two questions and then a lot of white space down that way, okay? And on that white space is where I'd like you to create your tables or do any kind of equations that you need to do. Okay, so here's our closing. All right. First of all, think about this. I want you to just maybe pause after this, after I ask this question, talk to your parent teacher or sibling or whomever. What does the scale factor tell us about the relationship between the actual picture and the scale drawing? Okay, so the relationship between the actual picture and the scale drawing. Now, we talked a lot about that. I tried to stress that today. There's a bit of a, I don't want to say argument, but there's a bit of a disagreement about using scale factor and the scale ratio. But this scale factor in particular, it is very useful because it tells us something about the relationship between the actual picture and the scale drawing. So take a few minutes, maybe pause, think about it, and come back. Okay, we're back. Yeah, and here's our answer. So the scale factor, it gives us an understanding of how many times bigger or smaller the scale drawing is compared to the actual picture. Okay, and this is why that scale factor is important. Okay, it's important and it's very special because of that. Okay. Alrighty. So what is our next question? How does a scale drawing differ from other drawings? Now, when we say other drawings, we mean drawings that aren't drawn to scale, which is like most of what we draw when we draw pictures of people and dogs and houses and flowers next to houses. We're not usually, most of us, we're not usually very good at drawing to scale. Okay, so how does a scale drawing differ from other drawings? Okay. Well, in a scale drawing, there exists a constant ratio of scale. Okay, a constant ratio of scale drawing length, the actual length. Oh, hold on a second, that doesn't make much sense. In a scale drawing, there exists a constant ratio of scale to between, should be between the drawing length, which is the scale drawing, and, sorry about this, and it would go right there, and the actual length. Okay, so there is always this constant ratio of scale between the drawing length and the actual length. Other drawings mostly do not maintain such a relationship. But again, there are many, like myself, and I know some of you have been in art classes before that I've taught, and we are very eager to draw more to scale to make things look more realistic. Okay, all right, and that's our closing. So from here, what I want you to do, therefore, is to go ahead and complete your exit ticket, do your problem sets for lesson 18, and also take a picture, take a snapshot of the mall floor layout problem with the two questions answered. Okay? So good luck with all this. Scale can be a bit of a bear at the beginning. Hopefully you guys are getting it, getting more and more comfortable with it. Okay? So good luck with everything.